Dear students, welcome to our science episodes. Today we are going to discuss matter construction. Matter construction. What do you think about these levels of organization of living things? An organism is made up of cells. Cells are the building blocks of any living organism. It is the smallest particles in a living organism. And similar cells form tissues, and then similar tissues form organs. And many organs together form an organ system and then an organism. Similarly, the smallest building unit of matter is molecules, not cells, of course, molecules. Let's discuss this activity together. Suppose you put some perfume in a glass bottle and measure its mass using a very sensitive balance. And then you open the bottle for a period of time and move to the other side of the classroom. After a while, you measure the mass of the bottle again. What do you observe? Can you smell the perfume while you are far away from the bottle? Yes, of course you can. And the mass of the bottle will decrease after leaving it open for a period of time. This is because the perfume has tiny particles which cannot be seen by naked eye. These tiny particles will be carried by the air and spread in the room. These tiny particles are called molecules. A molecule is the smallest particle of matter that can exist freely and has its own matter properties. Look to this oxygen molecule. It's formed of two oxygen atoms. This is the smallest particle of the oxygen is the oxygen molecule, the O2. Do molecules move? Let's see together. We will put a small amount of violet potassium permanganate in a glass beaker containing water. And we will leave the beaker for a period of time. What do you observe? What can you observe from this picture? After some time, the potassium permanganate salt particles will diffuse in water until all water color turns violet. And this means that the particles are in continuous motion and they will spread among the water molecules. Matter molecules are in continuous motion. Do molecules have spaces in between? Yes, they have. And we call these spaces intermolecular spaces. Let's add 200 centimeter cube of ethyl alcohol to 300 cubic centimeter water in a cylinder, of course. Measure the volume of the mixture. Surprisingly, what do you observe? The volume of the mixture is less than expected. We expect the volume of the mixture to be 200 plus 300 equal 500 cubic centimeter. But actually, it's 400. It's less than 500. Why? Because some of the molecules of the ethyl alcohol will distribute or will fill the intermolecular spaces between the water molecules. This proves that there are spaces between molecules. Intermolecular spaces are present among matter molecules. So now, can you give me a reason why does salt disappear after being dissolved in water? Where does it go? The salt molecule will spread in the intermolecular spaces among water molecules and dissolve. Now, try to fragmentize a piece of iron. Try to break it down by a hammer. and try to divide water, a large amount of water, into small cups, which is more easier. Breaking down a piece of iron or dividing water into smaller cups. Of course, dividing water. It's very hard to break down the iron. And this means that the attraction forces between the molecules are very strong in solids, such as iron. And the forces are somewhat weaker in liquid, like water. These forces are almost not found or negligible in gaseous substances like oxygen, carbon dioxide, and water vapor. These are the states of matter. Matter exists in three different states. Either it is solid, liquid, or gas. Let's together compare between solid, liquid, and gas. As you can see here, the solid matter has definite shape and definite volume, like this piece of iron, definite shape and definite volume. If you put it in a container, it will retain its shape and volume. What about the liquid? If we put some water in a cup, the water will take the shape of the container and it will have a definite volume. So liquids have definite volume and they take the shape of the container. What about gas? If you will watch the wind or the air moving leaves of the trees, gas has indefinite shape and indefinite volume. What about the intermolecular spaces? Here, the molecules are tightly packed, so the spaces are tiny, very small. The spaces here are somewhat large, but the spaces here are very large. Molecules are far away from each other. What about the forces of attraction between the molecules? They are very strong in solid, weak in liquid, and negligible or they do not exist in gas. Do molecules move? Yes, molecules are in continuous motion. In solids, they vibrate in their place. They shake in their place. In liquid, they slide past one another. And in gas, they move rapidly. Here are some examples for solid: ice, iron, aluminum; liquid, water, oil, alcohol; gas, water vapor, oxygen, and carbon dioxide. Here are some questions for you. Why do solids keep their shape and volume, even with the change of the shape of the container? What is this? Can you see this? This is a mouse. It's solid, of course. Imagine that I will put this mouse in a cup. What do you think? Will it take the shape of the cup, or it will keep or retain its shape? Of course it will keep its shape. What if I try to press it hardly? Will the volume change? No, the volume will not change. This means that solids have definite shape and definite volume. Also, the intermolecular spaces between the solid molecules are so tiny, and the forces of attraction between the molecules of solids are very strong. So that's why they keep their shape and volume. Choose the correct answer. Which matter keeps its shape and volume even if the shape or the volume of the container changes? Solid. The intermolecular spaces are very large in gas. State whether the statement is true or false. Molecules of the same substances differ from one another. False. Why? Because the same substances have same kind of molecules. What if the water in the river and the water in the cup, both are water, so the water molecules are the same. Molecules of solid matter vibrate in their place. This is true. The volume of a mixture of water and alcohol is equal to their volume before mixing. No, this is false. The volume after mixing will be less than the sum of their volume together. Dear students, thank you for watching. See you later in other episodes.